Okay, let's get started. Okay, so there's 3 different ways in this unit. We're going to express a linear relation. So we can have a slope y-intercept form is a form y equals mx plus b. So we're going to learn about that formula. This unit, slope y-intercept form. So you can see the slope of the equation. You can also see the y-intercept. That is why it's called that. We're also going to learn about point slope form, which will look like y minus y1 equals m times x minus x1. And that formula is actually derived from the slope formula. It's very similar looking to the slope formula. So that's where it comes from. And then general form. General form is ax plus by plus c equals 0. Okay? So we're going to write our equation of lines in these 3 forms. So our goal is usually to write the equation. Most of the time we want it in the very first form. It's the most useful form, the slope y-intercept, because we can actually easily graph it when it's in that form. Okay? So we're going to grab our graphing calculator. And we're going to just do a rough sketch of each one of these. So grab your graphing calculator. Yeah. Scroll up. Yep. And move out of the way. Oops, I deleted something. There it is. So why don't you take your graphing calculators right now? You don't have to worry about making it precise. I just want you to do a rough sketch of each one. So graph it and then rough sketch. Do you remember how to type it in? So where do you go to first? Y equals, very top left button. Okay, something's there, you can just clear it. And then we're going to type in the equation 3. Where's the x?
Under mode.
Under mode beside alpha. Okay, that xt alpha theta n. And then plus 1. And then how do we actually see the graph? Graph. If your windows are weird, how do you reset them? Zoom, so the middle button. Zoom. And then standard is 6. Okay? So just do a rough sketch of what you see there, okay? And so go through each one and do a rough sketch of each one, okay? Something like that. Okay, so your graph should look something like this. So we're going to focus on linear relations only. Tell me each one if it is linear or it isn't. So the very first one, linear or not? Okay, linear. Good. It is linear. Second one, is that linear? Yeah, straight line. You can also tell by just looking at the equation. Is it a degree 1 equation? Yes. Second one. No, this is actually what we call a cubic. Why do you think it's called a cubic? Power 3. This guy, linear? No. Quadratic. Which is funny because When you think of quad, you think 4. But this time, sometimes it doesn't. This guy, would this be linear? That look like a line to you? No, that's what we call a rational expression. I'll learn about that in Math 20. Good times. Not linear. Second one, or I guess it would be 6th. Linear, yeah. This guy, linear, and the last guy. Definitely not linear. You want to take a guess what it's called? Nope. Where's the x? In the exponent. It's exponential. It's growing exponentially. So the equations that we already listed them, linear versus nonlinear. So notice that with the linear ones, yeah. Yes. Nope. Okay, what do you remember from exponent laws? If I want to move the x to the numerator, what happens to the exponent? Yeah. So it actually isn't degree 1. It's degree -1. Yeah, no problem. It looks like it, right? Just because looking at it, yeah, look, their exponents are 1. But it's, you can't have, for a linear equation, that your active variable can't be on a denominator. So it's actually a negative exponent. Okay, so we're going to learn about specifically this equation before. You've kind of seen this. You've talked about rate of change in grade 9. So y equals mx plus b, where, what do you think m stands for? M is your slope. Okay, that's your rate of change. We know how to find slope. We've been finding slope the last 2 days, right? And b, anyone want to guess? Okay, well then, close. Y-intercept. B is your Y-intercept. So we can make the equation of any linear equation if we know the slope and the Y-intercept. You need to know 2 points. As long as you know 2 points, you can always find an equation because you'll know your slope, and once you know one other point, if you don't know the Y-intercept, we're going to use a different equation, but we can still make an equation. We just need 2 points. So let's look at this graph here. Notice how the equation is y equals 2/3 x minus 1. Okay, so notice what's the Y-intercept of this graph? Do you see it? -1, it's right here. And the slope is 2/3. So what direction? If we compare that to rise and run, we are moving right how many? Right, so up, it's rise first, up 2, and run 3, or right 3. Up 2, right 3. Okay, and there's that line. So if we look at, let's just skip down to C, the graph that we're talking about in C. We have 2 equations here, okay? So if we look at this equation of y equals 2x plus 1, what's the slope? Just by looking at this graph, what's the slope? 2. Okay, the slope is 2, or 2/1. If we wanted to write it as a fraction. Because, here's the graph, you can see they're going up, rise 2, right 1. 2/1. Slope, we always want it in terms of a fraction, so if it's a whole number, we write it over 1. So we can see that movement. What would be the Y-intercept of that graph? 1. Okay, you can see it's 1, but you can also see from the equation, the constant in the equation is your Y-intercept, is your B value. Okay, the second graph, what's the slope for this one? Positive or negative? Negative. And we're going to apply the negative to the top so that we're always moving right. So that what I mean by that, the rise is -5. So if your rise is -5, you're going down 5. Good. And if your run is +2, you're going, your run, right 2. So down, notice, down 5, right 2. Down 5, right 2. Okay. And the Y-intercept of this equation? -3. You can see it on the graph, but you can also see it in the equation, right? The constant is your y-intercept. It's your initial value. Why? Let's think about why that is. The y-intercept occurs when who is 0? X. So if I plug in x is 0, 5 over 2 times 0, or -5 over 2 times 0, is 0, and 0 minus 3 is -3, right? So when we make x 0, that's why the constant is the y-intercept. Okay. So if we look at this equation, we know m is the slope and b is the y-intercept. That's the big thing for today. Okay? Not so bad? Is that equation on your formula sheet? Yes. Sure. They all are. Yeah. They don't tell you the name of them. They do? Oh, well, life is good. They even tell you the name. They give you everything. No excuses. All right, so let's look at this graph. So if you're given an equation like this, 2y equals 5x plus 8. The problem is it right now in this form of y equals? No. In order for us to actually know the slope and the y-intercept, the y has to be isolated. It has to be by itself. So just divide everybody by 2. So if we divide everybody by 2, the equation will become y equals 5 over 2x plus 4. Does that match the graph? So 4 is the y-intercept. Is that what we see on the graph? Yeah. 5 over 2 is the slope. Are we going up 5, right 2? Yes. Okay. So the slope was 5 over 2. The y-intercept was 4. So notice how the slope is not 5. They're saying explain why in this case the slope is not 5. Well, it's not 5 because y wasn't, right, y. Exactly. Wasn't isolate, wait. Okay, Prego brain. Why can't I spell isolated? No C, right? What's going on with me? That's better. There you go. Don't know why I could spell isolated. Okay? And that's true for both of these. The y-intercept wasn't 8 because y wasn't isolated. It has to be y equals mx plus b. Y has to be by itself. Alrighty? Got it? Okay, let's look at the next page. Oh, no, not yet. Okay, so really quickly, what's the slope in this first one? 3. What's the y-intercept? 2. What's the slope in this one? -2 over 3. So it's the coefficient of x. This is in the wrong order compared to the equation. Whatever the coefficient of x is, that is your slope. The y-intercept would be 7. So you could also rewrite this equation as -2/3 x plus 7. Can we look at this and find the slope and y-intercept yet? No, what do we have to do? Divide by 6. Everybody by 6. Y equals, can that reduce? What does it reduce to? 4 over 3x plus 1 over 6. So slope is 4 over 3. Y-intercept is 1 over 6. Okay? So once y is by itself, you can see your constant, which is your y-intercept, the coefficient. I think that's how you talked about it in grade 9, is the constant and coefficient, right? The coefficient is your slope, your rate of change. Yay. Last page. So let's do some graphing. State the slope and the y-intercept. What's the slope? 2. What's the y-intercept? -5. Okay, so our first step when we're graphing is to plot a point. Which point do we know? The y-intercept. So let's plot the y-intercept. So on the y-axis, we want to plot -5. So right there. Okay, so you always have to start with a point. Then we want to get more points, because then we can connect it and draw a line. So we're going to use our, we're going to use what? Our slope. Okay, now, if our slope is 2, it's 2 over 1. We want to make it a fraction, okay, because we want to know our direction. We want to know our rise, and we want to know our run. So if my slope is 2 over 1, that means we're going rise first, up 2, right 1. And it should always be right. If we apply the, if there was a negative, we always apply it to the y, to the rise. Okay, and then this way it's always right. So up 2, right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. Follow that pattern. Everyone want a ruler? They're on the shelf. Just grab one. Calculator lids work too. Or you can just sketch it. So let's draw that. Connect that. Okay, so an equation, it's not a word problem. We're always going to connect these lines, okay? And I want you to draw it all the way to the edge of the graph, both sides. Don't just, if you just only draw a couple points, don't just connect those ones. This graph continues. The domain is XER, the range is YER. It continues forever to the left, to the right, up and down. Okay, it continues. You can check with your graphing calculator. So how do I check with my graphing calculator? Okay. So I can look, y equals 2x minus 5. There's two things I can do to check my work. One is just looking at the graph and seeing if it looks the same. So I push, Harsh, you with us? Okay, push what? You can, so graph, and then we can push trace if we want to see different points. So if you want, you can go trace. Well, mine already, did yours automatically show up at the y-intercept? Yeah, that's nice. So there's that. And you keep moving, or trace, 1, enter, 2, enter, 3, enter, right? You can verify those points. 4, enter. There's those coordinates. So they match your coordinates. Another place you can look for coordinates to see if they're the same is your table of values. Where's the table? Second, so the second button, blue, and then the graph button. You can see it says table up above there. Second graph, you can see a table of values. You can check that the coordinates are the same. Okay? All right. Let's try one more. 2/3 x minus 6. Do you want to try it on your own? No? What's the y-intercept? Close. -6. So keep the sign with -6. What's the slope of this graph? 2 over 3. So we're going to move up to right 3. Up to right 3. Too bad this wasn't a negative one. I should have changed it. Okay, it says algebraically determine the x-intercept. We'll do that after. Let's graph it first. Oh, that is not. This is why I like to use a ruler. So what do you get as your x-intercept just by looking at this graph? Okay. Do you get 9? So how do we algebraically determine the x-intercept? Do you remember? You set y equal to 0. So 0 equals 2/3 x minus 6. And we solve for x. First step. Plus 6, which gives you 6 equals, thank you, 2/3 x. All right, there's a couple things you could do. You can either, okay, you can divide 6 by 2/3 and put it in brackets in your calculator. You can do that. You can also just start by getting rid of the fraction by multiplying both sides by just 3. Okay, so that gives me 18 equals 2x, or x is 9. Okay, either or, you get 9. So 9 and 0 would be that point. Just to review, it says verify with your graphing calculator their intercepts. So let's review how to do that. Grab your graphing calculator. Let's type in this equation. 2/3 x. Which way do you want me to move it? This way? Yeah. Okay. So we're going to verify our intercepts. So push graph. How do I find, on the graphing calculator, how do I find the y-intercept? Trace, and it actually is already there. Or trace 0, enter. Okay, -6. So that's good. How do I find the x-intercept? So go to y equals, y2 equals 0. Okay, so because the x-intercept is when y is 0, we can't actually, so we're going to make another equation, y equals 0. I'm going to graph it. And then second, trace to go to the calculate button. 5 for intersection. Enter 3 times. Okay, and I'll find the intersection, which is 9 and 0. This is what our x-intercept is. Okay? Good little review there. Which is helpful if you want to check your work this unit. Do you need it? Could you get through this whole unit without using the graphing function? Yes. Okay, on your calculator. Absolutely. Okay, so we're done the lesson. That's it. Yeah, nice and short again. Isn't that nice? Okay, circle the following. Number 1. Number 2 is ACE. Number 3 is B and C. Number 4, all. Oh, I should talk to you about a question. We're going to go to your homework in a second. 5A and C. 7. Oh, where'd 7 go? 7, all of 7. Then 8, just the first one. Number 1. Okay. 10 and 12. Okay, can we go to back to number, I think it was 4. Okay, this guy. It says for each graph, state the slope and y-intercept. Graph the equation without a graphing calculator. All right, if you're comparing this to mx+b, do we know the slope, or do we know the coefficient, or do we know the constant? We know the constant. Is there x there? No, this is the constant or the b value. Okay, so your constant, your y-intercept is 5. What would be your slope? 0. 0 times x is 0, so that's why we have no x there. Okay, your slope is 0. What kind of line has a slope of 0? A horizontal line. Right? So here's my y-intercept. And it will be horizontal. So if you ever have an equation that's y equals a constant, some constant, then it's going to be a horizontal line. If you ever have x equals a constant, for example, x equals 2 is your equation, guess what type of line that will be? Vertical. It's a vertical line. Okay. And what's the slope of a vertical line? Undefined. You have to be undefined. Okay, so just careful if you ever come across equations where you have just x equals a constant or y equals a constant, that's when it's going to be a vertical or horizontal line. Okay? Alrighty. You may begin your work. One at a time. Sort it out. After these two are done. Yep. One at a time. Oh. You're almost as bad as I am, all these bathroom breaks.